Everyone just dismissed for Thanksgiving holiday. I'm going to get this taken care of so we can move on. We are going to be talking about naming acids and covalent compounds. Now, acids technically are all covalent compounds. All right, they are not ionic, although the 6 strong acids do dissociate in water. So we'll start with acids. When you're looking at the compound formula, if the compound formula starts with an H, it's an acid. So then you look what's next. Does the H, is it attached to just a non-metal, or is it attached to a polyatomic ion? Right? That is what makes the difference. So we're going to talk about, first of all, is it attached to is it binary? Is it attached to one non-metal element? If it is, the way we write that is hydro, then you put the name of the ion, so for bromine, and then you put on ic. Hydrobromic, I guess there's no N there. Hydrobromic acid. Sometimes you kind of have to fiddle with them a little bit. I'll be fairly lenient on that. Hydrochloric acid. The chlorine, hydrochloric acid. So instead of hydrogen chloride, which you look at that and that's what you want to call it, hydrogen chloride, it's hydrochloric. If we have this guy, starts with an H, we need 3 hydrogens to bond with 1 nitrogen, because nitrogen it needs 3 more electrons to be happy. This guy would be named hydronitric acid. Okay? All right, so let's practice. We did HBr already. We did HCl already. We'll do HI. We'll do H2S. We'll do HF. All right. So, we said that the pattern is hydro, then the name, or the root at least, of the anion, and then ic. Hydrobromic acid, hydrochloric acid, hydroiodic acid, hydrosulfuric acid, and hydrofluoric acid. Okay? Next, if that's for a binary, what if it has a polyatomic ion? So what if instead of HBr, we had HBrO3. Well, this is a polyatomic ion. What's its name? Well, we can look at the back of our periodic table, and BrO3 is bromate. So make it bigger. Right there. Okay? So, bromate. The way we name anything, these are called oxyacids sometimes. The way we name acids that have an oxygen in them, or a polyatomic acid, is we drop the hydro. So hydro is now gone. We put the stem, brome, and then if this is hydrobromate, the 8 gets dropped and we get ic. If we had HBrO2, which is bromite, the hydro gets dropped and we have bromite changes to bromus. Okay? So let's practice some of those. We'll do one of the more common ones. Sorry, I should have had these all written out already. So, we're going to drop the hydro. So it's just, we look here, his name is nitrate. And we erase 8. And we put ic. This guy is nitrite. We erase ite. And put us. Sulfate, we're going to drop the 8, and really this is one of those that's kind of bizarre. It should be sulfic acid, but for some reason we leave the in there, so it's sulfuric acid. That's just kind of a wonky one. So if this is sulfite, guess what he's going to be? He's sulfurous acid. Phosphate will be what? And again, phosphate, you should think, well, it'll be phosphic. It's phosphoric acid. So they don't follow the rules exactly. I'm sorry. Get over it. This guy, oxalate, becomes oxalic acid. All right. Let's see. Let's take some more from our ion chart. So, chromate would be chromic acid. Carbonate would be carbonic acid. Tartrate would be tartric acid. Permanganate would be permanganic acid. Hopefully you kind of have the idea. We will practice those more next week. All right, on to naming covalent compounds. Hopefully this is something that you all remember from Chem 1, because we're going to use prefixes and suffixes again, just like we just did with the acids. The difference is, and this is what kills me about when we start naming covalent, you guys all of a sudden go nuts with these prefixes and suffixes. Covalent compounds are made of nonmetals that are together. Okay? So if it starts with a nonmetal, unless it starts this, which is an ion, if it starts with a nonmetal, you get to use the prefixes. If it doesn't start with a nonmetal, we don't use the prefixes. Prefix for 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa. Hang on. Seven is hepta, 8 is octa, 9 is nona. All right, so let's practice some of those. Oh, let's talk about exceptions. The exception is if the first element is a single by himself, we can drop the mono. And if you're using oxide, instead of tetraoxide, it's tetroxide. All right, so let's practice. CO2, mono, carbon, but we don't need the mono because it's starting, so we can just say carbon, that's an N, monoxide. We do need the mono for the oxygen. No, that's not carbon monoxide, that's carbon dioxide. I already started this over 3 times. You're just going to have to deal with the mistake, sorry. Carbon dioxide, Di for O2. CO, we just have 1 oxygen, carbon monoxide. Either one is deadly if you breathe too much of it. SO2, once again, the sulfur, there's only 1, sulfur dioxide. This guy's going to be sulfur trioxide. Nitrogen and oxygen. Well, how am I going to name this guy? Dinitrogen. Now, can I just say oxide? No, I have to have the mono in there. And remember, if you've got an oxide, you can drop the if the prefix is in a vowel, you can drop it. So instead of saying monooxide, you can say monoxide. NO is just going to be nitrogen monoxide. N2O3, dinitrogen trioxide. NO2, nitrogen dioxide. N2O4, dinitrogen tetroxide. N2O5, dinitrogen pentoxide. Okay? Hopefully that makes some sense. Now we'll look at some and go the other way. By the way, if you feel like you've got this, move on. You don't need to watch the rest of the video because all I'm going to do is finish this. If you want a little more practice, keep watching. We will work on this on Tuesday. First one, phosphorus trichloride. That means we have 3 chlorines. Phosphorus pentachloride means 5. Nitrogen trihydride. Hydride comes from hydrogen. How many hydrogens am I going to have? 3. That's also, the common name for that is ammonia. Sulfur hexachloride. Hexa is 6. Diphosphorus, 2 phosphoruses, pentaoxide, or pentoxide. Carbon tetrachloride. That's what we used to use to preserve dead things like dead frogs to dissect, but it's carcinogen, so we don't need more. Silicon dioxide, SiO2. Carbon disulfide, CS2. Oxygen difluoride, OF2. And phosphorus tribromide, PBr3. All right, hopefully that helps you understand a little bit the difference. Like I said, we'll have some practice next week. Have a great Thanksgiving.